Imagine that we have an idealized particle relative to a reflective field or medium. I've got it drawn here as a point particle, here, a dot, in front of a line which we've described as capital M. This point particle represents an energy and or light point. Imaginary, abstract, we can refer to as the Euclidean point. Here we refer to as Q equals quantum information. So as to inflect an aspect of my model, I'll refer to this information here, the dot, as the same as a real object positioned in front of a mirror. The mirror we'll call M, capital M, and represents a reflective vector that is separate from but relative to Q. We've deduced or stated as a prerequisite that the Q point represents energy or light. So if Q is relative to the M surface, then Q will be reflected to M as a body of reflected information that we'll call M. We're referring to the holographic principles here, information projected to screens. Here I've drawn the line as representing M, but this M represents, as drawn here, the plane or the dimensions of a mirror, and the information on the mirror, reflected on the mirror, is referred to as lowercase m, as in the Einstein equation. So if Q is relative to M surface, then Q is going to be reflected to M. We're speaking of duality here, transference, transmutation, whatever terminology you want to refer to, that the information from Q is stored on the surface or implanted, projected to the surface of the screen, and represents a body of information. The equation would be written as Q divided by M, Q, real particle, divided by M, medium, plane, reflected surface, equals the body of information projected to M, mass, holographic, equals Q squared. We'll get into what the Q, or the squaring of Q, represents, although it's already inferred or demonstrated as just basically being the relationship between a real object, a reflector, and its reflected images. So we're basically determining that Q is a zero-dimensional point that's relative to M, and therefore the surface of M records the information on its surface. The information on the surface of M is not the same as M. In other words, a reflected image on a mirror is not the same as the mirror, and vice versa. The mirror is not the same in the strictest sense as the information implanted on it. Two separate vectors. So the information on M is not the same as the plane itself, and due to M in the equation and as relative to and reflective of the Q particle, the information emerges as M on the surface of M. So this reflected body of information, M, referred to as lowercase m, of Q, it represents that the zero-dimensional information represented by the Q side, or the Euclidean dark energy side of the equation, has been replaced at this point of the mirror by a one-dimensional body of information existing on the surface of M, purely on the surface at this point. So as it is, Q still exists, regardless of reflecting itself to M, the plane, and therefore all three vectors are relative to each other and separate from each other. Again, we've just explained that the body of information, the image on the mirror, is not the same as the mirror. So in essence, in that sense, they're separate vectors. So Q is relative to M, the mirror, and all three vectors exist apart from but relative to each other. The surface of M is a one-dimensional plane, as drawn here. It has no real thickness. Despite that we can say that it has a length and a width, and it has certain dimensions along its surface area, it still represents one dimension, and the information on it is merely superficially representing a reflected body of information. It has no real thickness. Well, we've drawn it here as illustrated as a sphere or a bubble. So in other words, this line, and as illustrated as a plane here, is furthermore extended over here to the analogy of a sphere or a circle. That is, only the circumference represents the reflective potential. The information on the interior, inside the circle and outside the circle, is separate. This represents the plane, and the M represents the projected information to the holographic screen, which is the same as the projected volume of information here. I've drawn this up here as the plane. We see a light ring. This light ring represents the volume of information encompassing the M on the sphere. This light ring will expand or contract proportional to the distance between this real object to the plane. If this real object goes farther away, this circle expands. If it goes closer, this circle will contract. And this just merely is showing the relationship between reflected information on a plane surface relative to both the object and the motion of the object as effecting change to the information as projected to the screen. So, again, this is drawn as a sphere bubble. This represents a plane, and here the equation is just drawn as a dot with a line. All three, the line, the plane, the surface of the sphere, represents the M vector, or medium. And we'll get into dark matter as related to this M medium as we continue. So the same is true of the M, the information that exists on the mirror. It exists as a reflected volume of information just on the surface, so therefore it's considerably one-dimensional. And again, we've described it as just a mere light ring existing on the surface of a plane or surface of a sphere bubble. So the relationship of one isolated mirror, and here what's just drawn is a dot in front of one mirror. This mirror is isolated from any other mirror. It does not reflect to and from another mirror. It's merely reflecting the information from the particle side. So it dictates this relationship of an isolated mirror relative to invisible information. And of course the mass would represent the observable, measurable information. This quantum is mathematically inferred. This dot is mathematically inferred existing relative to the mass holographic information. So the information on the screen is merely one-dimensional. So the relationship of one isolated mirror relative to Q dictates that the information of Q can only be represented or replaced with an M or one-dimensional body of information on the plane. So we can deduce that the surface of the mirror, the M surface of the mirror, represents the potential beginning of a string. And what that means is so long as this line is in the equation and can potentially come into relativity, or vice versa, this particle dark energy can come into relativity to the plane, then there is a potential that there could be a dual form of the point particle to a point here on the mirror, body of information. So this M, this reflective medium, represents a potential. It's related to the Heisenberg uncertainty principle, and we'll discuss that later on. So this mirror represents the potential that invisible light can be reflected in a way that now it can be observed mathematically and measured. So the relationship of one isolated mirror represents that only one body of information will be reflected to its surface. So we refer to this beginning where the first point where quantum information is reflected. We can refer to that as the potential beginning of a string, and we'll come to understand what these abstract strings represent. Some of it's consistent with up and coming string theory. Many aspects of it isn't, but refines these models. So this string point, the information on the surface, this string point merely represents the beginning of a reflected system. So we can call this M point a static point relative to a fluid state of information existing on the quantum side. This is the fluid Euclidean point. This is a static, and of course we'll get into this being a closed system, and of course we'll expand that even into descriptions of the vacuum states and all of that. So this is the static reflective point or beginning of a string as separate from the fluid condition of the Euclidean information. So this string merely represents the beginning of a reflected system. So we can call this M point a static point, and we can come to see that the birth point of the string has the potential of expanding the one-dimensional M point to many M points. Basically, the string can be stretched or lengthened, but so long as we only have particle relative to one isolated mirror, we can't extend this string any further than that. There's another element that has to be introduced in order to make this information on the surface turn into M2, M3, M4, into infinity. There's another quality that has to be introduced, another relativistic attribute to the equation that has to be introduced for that to happen. But at this point, being isolated, there's only one body of information that can be projected.